Okay, so adding to our toolbox here of things we can do with the Pythagorean theorem, I think what we did on Thursday with the kind of using it as a test to see if it works as the triangle works as a right triangle, that's great. And we can also kind of adapt that a little bit and check to see if it is an acute triangle or acute or an obtuse triangle. So literally, if I give you a triangle, you can tell me if it's acute, right, or obtuse. And those all kind of use this little take on the Pythagorean theorem. So what you need to keep in the back of your mind is the biggest side is your C value. Okay, I'm going to give you a triangle. You're going to run this little test, and you're going to tell me if it's acute, right, or obtuse. Keep the biggest side off by itself when you do the math. The other two you can scramble up as the A or B. So the way this works, and there's a little bit more information here than the other day, but it looks very similar. You're going to compare the A and B squared values to the C squared value, just like we did on Thursday with if they were equal. But now, if they're not equal, what does that mean? Well, if the A squared plus B squared is bigger than the C squared, if the C squared is smaller, it's an acute triangle. If the C squared is bigger, it's an obtuse triangle. And then again, like what we had on Thursday, if it is dead on equal, it is a right triangle. So you're going to have to kind of keep all of these straight. For me, I focus on the C squared value. If the C squared is smaller, your angles are smaller, so it's acute. If your C squared is bigger, your angles are bigger, it's obtuse. Focus on that one and kind of just keep that little bit in your head. If C squared is equal, it's right. If it's less, it's acute. If it's bigger, it's obtuse. Okay, so now these are the exact same numbers that we had the other day. I thought it worth kind of lumping it all together because I think we only had one of them that was equal. So you're going to compare these values. Pretty straightforward here. I've got a 6 squared and an 8 squared and a 10 squared. Okay, if you have a scientific calculator, you can type in that left-hand side the whole thing all at once. 6 squared plus 8 squared is 100. You're comparing that to 10 squared, which is also 100. So those values are equal. That is a right triangle. Your homework is going to be multiple choice. I'm going to give you a triangle, and your options are going to be acute, right, or obtuse. You just pick the right one. You have to be able to do the math to back it up, though. So on this one, I got 9 squared plus 10 squared, 15 squared. How does that compare? Well, 9 squared plus 10 squared is 181. 15 squared is 225. C squared is bigger. That is obtuse. 3 squared plus 5 squared compared to 7 squared. That is 34 compared to 49. C squared is bigger. Again, obtuse. It's the same test. It's just what do you do with the results? 9 squared and 13 squared. Compared that to 15 squared. Now that one I can't do in my head. 9 squared plus 13 squared, that is 250 compared to 225. C squared is smaller. That one's acute. 10 squared plus 12 squared compared to 15 squared, that is 244 compared to 225. C squared smaller, that one's acute. And then 4 squared plus 8 squared compared to 10 squared. Let's see, 4 squared and 8 squared, that's 16 and 64, that's 80 compared to 100. That one's obtuse. Okay, it's an easy test, but it's easy to get it confused on because of the less than greater than. Focus on the C squared value. If it's big, it's obtuse. That's what an obtuse angle is. It's a bigger than 90-degree angle. If it's less than 90 degrees. Focus on that, and I think you'll be all right.